Hello, welcome to another section of Math. Today in this video we'll be looking at how we can use DI method and trig substitution to solve this problem. We are going to use trig substitution and DI method to solve this problem, which is integral natural log of x into bracket x squared plus 1 dx. What make this one an integration apart question is because it's an integration apart question because we can consider the coefficient of what the ln, which is what 1. The moment you consider the coefficient of what the ln, which is 1, it becomes what an integration apart question. I don't know, you can try other approach, use up partial fractions, other approach, maybe it will work out. Yeah, but maybe if you try use substitution and then partial fraction, other approaches to solve this one, you can let me know. But here I'm going to use DI method, which is the same as the traditional approach, and trig substitution to solve this problem. So without wasting much time, let's get started. Okay, so let's bring this integral question down here. Good. As I said, because we have considered the coefficient of ln, or the whole of natural log x squared plus 1, which is 1, it has become what? An integration apart question. As I said earlier on, maybe you can use substitution to solve it, maybe partial fractions, maybe other approach, maybe other integration formulas that there may be another, or some, maybe you can use maybe some integration formula to solve this problem here. But maybe apart from the approach that I'm going to use here, if you use partial fraction, if you try partial fraction, trig sub, use substitution, and the other approaches, you can let me know. I'm not saying it won't work, though it will work. But here I'm going to use the DI method and then trig substitution. And I'm saying if you also try any other approach, as I'm going to let you know what the approach that I'm going to use, if you try other approach and you get your answer, then you can let me know the approach. Maybe if you try use up and you get your answer, you can also let me know. Okay, so as I said, we are going to use DI method to solve this. That is differentiation integration approach. Now here, the coefficient of this one is what? 1. So we are going to integrate that one, and then we differentiate natural log into bracket x squared plus 1. Okay, so let's draw our formats and let's put them in. Okay, here when you differentiate this one, first differentiate what is inside, what is in the bracket here, that is x squared plus 1. Differentiate that one first. Now when you differentiate x squared plus 1, ideally if you want to differentiate something of this nature, you use the chain rule. Okay, so differentiate this one first. That is when you differentiate x squared plus 1, you're going to get 2x, and maybe you did substitution, and here becomes what? U. Maybe you cannot do it the way as I'm doing, just substitute this one for another variable and then use the chain rule to solve it. Okay, so assuming maybe here become U, natural log of u, when you differentiate, you're going to get 1 over u, but u is equal to what? X squared plus 1. So you're going to get 2x times 1 over x squared plus 1, which will give us what? 2x over x squared plus 1. Now when you differentiate, when you integrate 1, you're going to get what? X. So this one will give us 2x divided by x squared plus 1, and then this one will give us what? X. Okay, here I am stopping here, or we are stopping here, because we can integrate the product of what? This and that. Okay, and with DI method, the moment you stop, you start what? Writing your answers. And how are we going to write our answers? Remember, answers from the DI method are always what? The product of what? The diagonals, that is this and then that. Okay, so the first part of the answer to this question is this one multiplied by this, which is indicated in this red arrow, or maybe orange arrow, or what. Yeah, let's say orange. Okay, and the next part is, the moment you stop, the product of diagonal, where you stop, the product of that particular row is what you are going to further work on, assuming you didn't get 0 in the D column, or provided you didn't get 0 in the D column. When you get 0 in the D column, you don't work on any other thing again, because the product of that particular row will be what? 0. So here, the product of this row, that is 2x over x squared plus 1 times x, which is indicated in this blue parenthesis, is what we are going to further work on. So when we multiply this by this, we are going to get 2x squared over x squared plus 1. But remember, because the row is negative and this are positive, our final answer to this one is going to be what? Negative. Okay, so let's write down our answers. Okay, integral natural log into bracket x squared plus 1 dx equal to x multiplied by natural log of x squared plus 1 minus, yeah, because of the negative rule, minus integral, this is what we are going to further work on, 2x divided by x squared plus 1 times x dx. Okay, so here when you multiply this and then this one, you're going to get 2x squared divided by x squared plus 1. Okay, okay, good. Okay, this is the first part of our answer. This one is the first part of answer to this question. So here we are going to further work on it to find out what answer we are going to get, or we are going to integrate this to get another answer, of which will be added to this one here. Okay, so without wasting much time, let's work on this one. But I will not include the negative sign. I will leave it so that when I come back, whatever I get, I just multiply it through. Okay, and I think that will be more safer for us. Or but I'm not saying if you carry it along it's not safe. It's safer for you to carry it along also, only if you know how to deal with the negative sign very, very, very well, because if you don't take care, it can confuse you and you can get your answer wrong at the end of the day. Okay, so we are going to bring this one down here. Okay, so here we are going to use trig substitution. Don't worry. Very soon we will start solving integral, which require full trig substitution from starting to the end. Okay, so we are going to use trig substitution to solve this one. You can use long division also. When you use long division, you get the same answer as what? Trig substitution, but I'm just using trig substitution here. Okay, so to use trig substitution to solve this problem, first you need a right angle triangle. So let's draw a right angle triangle. Okay, this is a right angle triangle. Then the variables here, x squared 1 and the whole of this apart from these two here, we are going to put them or write them on the sides of the triangle, but we do so according to what? Pythagoras theorem. Pythagoras theorem. Okay, so we are going to put this x here, and then we will put this one here. This side is what? The opposite. Don't worry, our triangle here doesn't have the right angle symbol, and also the theta is not there, but it's still a right angle triangle. Even the moment you see it, you can still tell that it's a right angle triangle. Yeah, even this and this are perpendicular, and the angle is 90 degrees. Okay, and this one is what? Our hypotenuse. Okay, so assuming our angle is here, it is opposite because that is the side facing this angle, and then this is adjacent, or yes, what the adjacent, because that is the line the angle is resting on, or this there is the side which is adjoining to the angle, what here. The angle here can be theta, beta, gamma, any variable at all which can represent what the angle. So I'll put x here, and then I'll put this one here, and then from Pythagoras theorem I'll just square this and square that one also, and whatever I get I'll just bring it here. Okay, so let's put our x here. If you put x here and then 1 here, and then you square them to get the hypotenuse, you have to find the square root of the sum of x squared plus what? 1 squared. Okay, so let's put them. Yeah, okay, this is our x, and then this is our 1 here. This side, the angle is here, so this side becomes our what? Opposite. But if I put the angle here, it's no longer, this line is no longer the opposite, but rather the adjacent. This line becomes what? The opposite. But here, theta is what? Here. Theta is what? Here. We didn't get anything to represent theta here, but no problem. We assume this side is what? Theta. So to get this hypotenuse using Pythagoras theorem is x squared plus is square root of x squared plus what? 1 squared, and that will give us square root of x squared plus 1 here. Okay, so now that you have put the variables and figures on the side of the triangles, or we are able to generate our Pythagoras theorem. Now let's look at how the various trig ratios can be applied here. That is, here you are going to use what we call SOHCAHTOA. Dealing with that right angle, we use SOHCAHTOA. Okay, so you just choose the one that will help you solve the problem easily. So here, if you take which is sine theta is equal to opposite over what? Hypotenuse. That will be x over this. Differentiating will be a little bit problem, or to take us a little bit long. And then if you take cosine, which is cos theta, is going to be this adjacent, which is 1 over this, the same thing. But when we take TOA, which is tangent, which is tan theta, which is equal to opposite over adjacent, which is x over 1. X over 1 will give us what? X. So I think that one is more easy than the first two that we considered. Okay, so we are going to choose what? TOA, which is opposite over what? Adjacent. So tan theta will be equal to x. Tan theta is equal to x. Good. Now let's differentiate. Always make it simple so that the differentiation will what? Will go faster for you, or will be easier for you. If you make it very, I'm not saying you when you make it difficult, when you choose sine, you won't get the same. You get the same answer, but it won't be all that easy for you. It won't be all that easy for you unless you know your differentiation and other algebra aspects as well. So now let's differentiate. Differentiate this one will give us what? Secant theta squared d theta, which is equal to what? Ds. When you differentiate this one, that is what we are going to get. Dx is equal to secant theta squared. Okay, now we know what is replacing this one, which is this. We also know what is replacing We also know what is replacing s, which is what this. So now that we know what is replacing this and this, let's put them into the integral. Okay, so when we put them into the integral, it is what is going to look like in the theta world. Now, on the numerator here, we are going to get 2 multiplied by tan theta squared divided by tan theta squared plus 1 times secant theta squared d theta. Okay, good. Don't worry about these two. It will surely come out here. Don't worry about it. It will surely come out here. You know, when you are working yours, the moment you get it, you can take it out. Maybe nobody cares. That is you. Okay, you can take it out the moment you get it. Only if you take it to confuse you. Don't worry about it. It will surely come out. Maybe somewhere in the next step. Now, what is tan theta squared plus 1? Which is tan theta squared plus 1 from trig identities, or from trig identities. Tan theta squared plus 1 is equal to secant theta what squared. So we are going to replace this one with what? Secant theta squared. Okay. Yeah, the two has eventually come out, so we don't have any problem at all. And all those who are worrying, who are just getting confused, I hope you are now safe. Yeah, me too, I'm safe. Okay, let's continue. Now, after replacing this one, this is what we have gotten: tan theta squared divided by secant theta squared times secant theta squared d theta. Okay, here secant theta squared will cancel out with this secant theta squared here, and to be left with what? Tan theta squared. Okay, now to integrate tan theta squared, here you can choose to do substitution. That is why I said initially that maybe substitution may work, but if you do it, you let me know, because I am showing you my approach of solving this question, or approach that I'm using to solve this question. So if you use any other approach, you also let me know. Okay, so here we are, you can do substitution and then it will still work out for you, but just that it's just that the workings will be more. So to make it very short, we know that 1 plus tan theta squared is equal to secant squared theta. So if we make theta squared from that equation, we are going to get theta squared is equal to secant theta squared minus 1. So if you are having theta squared here, we can replace it with secant theta squared minus 1. Okay, so let's replace it. Okay, here this one we won't split it because we know the answer to this. We also know the answer to this, and that makes it very easy. And I hope you know why when you integrate secant theta squared, it give you tangent theta squared. I hope you do. You don't worry, I've already done a video on that, a proof of why when you integrate secant theta squared, you get what? Tan theta, or you get what? Tan theta, or you get what? Tan x, or you get tan m. I've already done a video on that one, so you don't worry. I'm just going to write the answer to this one directly, and later on I will direct you to that video so that you can go and watch the proof of how or why when you integrate secant theta squared, it gives you what? Tan theta. Okay, so let's integrate. This one will just give us tan theta, and this one also I've already done a video on why is it that, on a proof of integral 1 being equal to theta, or b equal to x, or b equal to any variable at all, provided the derivative of what that variable is what's known. If the derivative of that variable is, let's say, m, it will give you what? M. Okay, so here is what? Theta. So here it will give us what? Theta. Okay, good. So the answer to this one is just tan theta minus what? Minus what? Theta. Now let's open the bracket. Now when you open the bracket, you're gonna get 2 tan theta minus 2 theta. Okay, now I've already told you before, and I'll keep on saying it until I see that a lot of us, many of us, has stopped making that mistake, or is now has gotten the understanding very, very well. Okay, 2 tan theta minus 2 theta. We move from x world into the theta world to solve our problem. I went to America to study or learn how to build cars, how to do that, blah 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 blah. With all other factors constant, if I'm done with my study, what do I have to do? Probably what? Return back. That is why I'm saying all other factors constant, because I may choose to stay. Maybe if the environment is conducive, if the environment is very cool for me, I can choose to stay. By January, if you went somewhere to do any work, the moment you are done with that particular work, you surely return to where you are living. So where we are living was X world and not theta world. We came here to do some work and now we are done. So we have to go back. Okay, good. And going back from the triangle that we drew, we saw that theta was equal to x, but we didn't see anything which was equated to what? Theta. But we can get theta from the equation we formed initially before getting into these workings. That is, tan theta is equal to x. We can take tangent inverse of both sides, and that will give us what? Our theta. Okay, so we know that tan theta is equal to x, and then theta is equal to what? Tangent inverse of what? X. Why? Because not from the diagram, maybe from this one or from the first equation, tan theta is equal to x. If I want to get this theta here, from trigonometry, don't worry, you'll be doing more about trigonometry, integral that require trig substitution. So you don't worry, you're getting to know why I'm saying all these things. To get your value, or to get the value for this theta here, we have to take tangent inverse of both sides. The moment you take tangent inverse of this one, it cancels out with this tan here. It cancels out with this tan here. And the moment it does, it will be left with a theta. And when you take tangent inverse of this, you're going to get tangent inverse of what? X. But we don't have any similar thing to what? Cancel out with it. So it just gets what? Stuck there. And by that, we will get theta is equal to tangent inverse of what? X. So here I've written tan theta is equal to x, and then theta is equal to what? Tangent inverse of what? X. That is going back to the x word. Wherever we see tan theta, we are going to put this one there. And wherever we see theta, we're going to go put what? This one also what? There. Okay. So let's put them. Good. You're going to get 2x minus 2 tangent inverse of what? X. So this is the answer. This is the second part of the answer in the x word. Remember, we have two answers. So the first one and then this one. So let's put them together. Okay, integral natural log of x squared plus 1 dx is now equal to natural log multiplied by x multiplied by natural log of x squared plus 1 minus, remember, I've already told you why I didn't carry the minus along it, because of something like this. If we had taken the negative sign along, this side could have become 2 tangent inverse of x minus 2x, or maybe it could have reflect in some of the workings, and then could lead us to getting 2 tangent inverse of x minus this one. Okay, but to avoid confusion, or maybe to make everything clear, to get the understanding very well, I always submit it, and when I'm done, when I come here, carry it along and doing it this way, which one is more safer or which one is more easier. See, when you open the bracket, you can easily write the answers here, because we know we are more familiar with something like this than that. Or Yeah, I heard the other guy saying, yeah, we know, or we are more familiar with something like this. We know how to deal with something like this than the other one. Okay, but I'm not saying when you get some in your integral, you won't be able to do it. When you get some, you surely know how to do it. But you don't worry. Maybe next time I will carry it along and I will show you how to handle it. Okay? Yeah, sure. Don't worry, we will do one on that. Okay, so now let's open the bracket. Okay, let's open the bracket. Okay, when you open the bracket, this multiplied by this will give us minus 2x, and this one is what? Negative. This times this will give us what? Plus 2 tangent inverse of what? X. So the answer to this integral is what? X multiplied by natural log of x squared plus 1 minus 2x plus 2 tangent inverse of what? X. But we are not done. We have to add our plus c back. Okay, so let's conclude. Therefore, this integral here is equal to the whole of this plus c. Don't worry, we have changed it, but remember, is still commutative. They are all what? The same. Either we bring this one first and then we subtract this and then we bring this one last. They are all what? The same. It will give us the same value, assuming if it were to be a definite integral. Okay, so the answer to this question here, integral question here, is what? 2 tangent inverse of, you can still maintain it this way. You are not wrong, you are correct. Don't bother also writing it this way because we did it this way. No, the answer is 2 tangent inverse of x plus 2 minus 2x plus x multiplied by natural log of x squared plus 1 plus c. This whole thing here is the answer to this integral question here. But I don't know, you try differentiate this one to find out if you can get this. If you do so, can you let me know? Leave it in your comment section. Yeah, you leave it in the comment section. Maybe you come back to watch it again. Okay, all right, all right, all right. It's cool. No, it's cool. Well, I hope everything is clear, guys. Well, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.